Yo guys, what are you telling me? Wagwan, wagwan. Who haven't I said hello to? Yo Sophia, sup Linton, hey Amira, Super's near, what's up? What's up Uma? Took YouTube 3 days to let me type here. Why? What have you been doing, man? Has YouTube banned you or something? Getting up to mischief, innit? What's up, Carlos? Yo Madu. What's up, Moneyball? How many do we have here today? I'm not sure. I'm streaming from OBS, so I don't actually see how many people are here. But wagwan, everyone. Hey, Siva. 30 seconds late, Matthew. How could you? Do you guys get detentions if you're ever late to lesson? Yo, Neutral. Yo, Addy. What's up, Cameron? Hey, you crook. Man like Zane, what's up? Yo, Ism. How's the PC keeping up, Mateo? You saw my Instagram story. At the moment, it's holding up. But yesterday, I got a heart attack. Do you guys know what I'm on about when I say the blue screen when you turn on your computer and then it says it's in repair mode and you just get a heart attack because you think that your computer's broken? I got that yesterday. I was dying. Hey Jenny. Gustavo. What's up, Abdul? No detentions in college. What? Cameron, you get too many liberties, mate. In my old school, if you were late by like 1 second, that's it, mate. You you have detention after school for an hour. The blue screen of death. Carlos, if I was to upgrade my computer, I'd be spending a lot of money, man. Yeah, 7 mark hypothesis testing. I'm gonna do that today, actually. So, guys, today we got the binomial distribution. The thing about the binomial distribution is I don't think it's explained very well initially. So, especially when it comes to hypothesis testing. So, my attempt today is to familiarize yourselves with binomial distribution hypothesis testing, because the same ideas I use in year 13 for uh, normal distribution hypothesis testing. So we'll see how we go. But guys, as always, you know the stream rules. Whenever I finish a question, you can spam Noise in the chat. You can spam some Lun Gang in the chat. You can spam Gus Gang in the chat for Gustavo. What else is there? That's it. My mind's gone blank. Which chapters am I covering today, Abdul? I don't know. Everyone uses a different book. So just the binomial distribution. Or L. Ellen. Yeah, exactly. You can spam some L. Ellens in the chat as well. From Edexcel. I don't remember, Abdul. It's towards the end of the statistics chapter. So in year 12, statistics is much larger than mechanics, but when you get to year 13, mechanics is much larger than statistics. So we'll see how you get on. All right. If you're watching on TikTok, what's up? Head over to YouTube so you can interact with me and the rest of the Lun Gang. Ellen me. You guys don't like stats. Well, in the exams that the year 13s just did, the stats section was definitely harder than mechanics. Mechanics is actually quite simple. It's very procedural. It's like a very nice extension on pure maths. So yeah, statistics though is like hit or miss. But I definitely prefer mechanics. Did you guys see my hypothesis testing question on TikTok about Mosey and I think it was, who else did I put? Was it Bob or something? Can't remember. But for the binomial distribution, remember guys, this is a revision session. So I'm not going to show you exactly where the binomial distribution comes from. But essentially it's to do with permutations, to look at the number of combinations of arranging certain objects. Yeah. So what you should have already learned about the binomial distribution is that, what's up Ibrahim, is that you can model a random variable x. So x is like an event happening. Yeah, so think about any situation like flipping a coin, I don't know, looking at the heights of people. X is just an experiment or an event. Yeah. If you can model this event with the binomial distribution, you have to satisfy certain conditions. Yeah, otherwise you would have to use something else. So the first one is there's a fixed number of trials. Yeah. So if you're flipping a coin, you can only flip the coin a certain number of times. Yeah, you can't do it indefinitely. I don't know if any of you guys are doing further statistics. If you're doing further statistics, you'll learn about something known as geometric distributions, negative binomial distributions, all of those things. These kind of distributions can go on indefinitely, but that's in further statistics. In normal maths, we only focus on the most basic binomial distribution, so fixed number of trials. Now, very important, you can only have success and failure. Yeah, you can't have any more than that. So people try and troll, right? So I tell them about flipping a coin, and then there's two options for flipping a coin, heads and tails. But what do you think some people also say? So I only say, look, either you get a tails or you don't. But what do you think some people who are yeah, some people think they're smart, innit? They're talking about, yeah, they think, yeah, the coin lands on its side. You always get the smart people who think they're smart, and they're like, what happens when you when the coin lands on its side? And I'm like, look, you can flip a coin, and you know, if you can get it to land on its side, then I'll give you £1 million. Don't quote me on it though, because I don't have £1 million. But if that ever happens, that's just an inconclusive experiment. You would have to repeat the experiment, yeah? But ain't no coin that's landing on its side, yeah? Not the penny coins anyway that we have in the UK. So the next thing is that the probability of success has to be fixed, yeah? And this is all theoretical probabilities. Here are my details, Neil. Seb, you're gonna do it for you're gonna be there for years, and I'll keep your bank details just in case. Did you expect 66% for an A? Alex, so I did predict that an A was going to be over 60%. You can look at my previous videos, my predictions. I said it would be at least 5% increase on wherever it was in 2019. So yeah, I'm not surprised it's 66%. The papers that were just done were really easy. If you go back, you guys will probably do them as a mock in the next year. But you'll realize that those papers were actually very, very easy, apart from one or two. Yeah. So I'm predicting that next year, the examiners have learned from their mistakes of making these papers way too easy, and make them harder. Yeah, I think it'll be much harder next year. But saying that, when I was doing my A levels, to get an A, you needed over 80%. Yeah, which is an A star now. So, you know, either they can make the paper, here they're kind of in the middle. They can either make the paper slightly easier and then go back to how it was before, where you need to get over 90% for an A star, 80 for an A, etc. Or they can then go back to where it was in 2019, where it was much harder paper, and the grade boundaries are much lower. But we'll have to see. I don't think we have enough sample size to kind of predict where examiners are going to go with this, because yeah, I think the papers that were just sat were quite fair, but that's just coming out of COVID as well, right? So people are still not at their full, because also the number of people who got A's and A stars was still higher slightly, the proportion, than it was in 2019. So, you know, we are still coming out of that phase. So I think next year probably will be slightly harder than the ones just gone. So how much percentage for us? Outlaw, I don't know. I would have to see what the papers are like when you sit them. The main thing though is you prepare for the worst, which is what I do with my course. In fact, in the next year with my year 13s, we're starting in 2 weeks now. Over the course of the year, we're going to go through 62 papers to prepare them. But yeah, I think back to normal next year. I think only people understanding what was an A star back in your day. So when I was sitting A levels, you had to sit 6 papers altogether. Wait, you had to sit 6 papers, and to get an A star in all of those 6 papers, you had to average an A. So you had to average over 80%. But in the 2 hardest papers, you had to average over 90%. And that's the only way you could get an A star, which is, you know, arguably more difficult than it is for you guys. You guys just have to average like 81% or something. When I was sitting it, you had to do 6 papers that were slightly shorter than the ones you guys are doing. You had to average an A in all 6. But then in the 2 hardest papers, and they were difficult, you had to average over 90%. And that's the only way you could get the A star. And I did it when I was 16, innit? So, alright, so with the binomial distribution, guys, you mainly use your calculator for all of this stuff. But in my full course, we kind of explore the formula a bit more and looking at the algebra. But us, because we're just doing a revision session, I'm just going to make sure you guys, you guys know how to use your calculator. So guys, everyone get your calculators out. So look at this question. It says x, so our distribution is distributed binomially 12, 0.25. Now 12 is the number of trials, and 0.25 is the probability of success. Yeah, some of you got the CG50 in that. I've got my class whiz. So if you have your CG50, I think you guys should know how to use it. Would you recommend the graphing calculator? I don't think so, Madhu. The graphing calculator is nice, but it's if you haven't used it since the beginning of year 12, I don't think it's worth it. So guys, on our calculator, we're going to go to number 7. Then we're going to go to binomial PD. So that's the probability distribution. Then number 2. So we're going to set x to be 2, n is 12, and the probability is 0.25. And then there we go. Now with the CG50 and cumulative frequencies, you can do lower and upper, that kind of stuff. But with probabilities, guys, just do 4 significant figures. It's usually the easiest way. Now, instead of typing, so you can type in 0. Yeah, guys, you can just type in 0 for the next one. But I want to explain in a slightly different way. So, guys, x is 2. Oh, sorry. X is 2 means 2 successes. Yeah? So 2 successes. What does x equals 0 mean? If you were to explain to someone probability of x equaling 0, what does that mean in English? There's 2 ways you can say. I want to see what you guys think. What's the 2 ways you can explain the probability of x equals 0? Zayn, I know you've been you got a good memory, my friend. I love to see it. Good. All of you are saying the correct thing that I want to see. Yeah. All failures or no successes. Yeah. So no successes, all failures. Yeah. So I'm going to write it as all failures. Yeah. Now, guys, in the chat, what's the probability of a failure? I see you, Abdul. What is the probability of a failure? And in terms of numbers, Madhu? Good, 0.75. So guys, remember 0.25 is the probability of success. So failure is 0.75. Yeah? But what power do I need to raise that to if every single trial is going to be a failure? What power would I have to raise 0.75 to indicate that every single trial I do is a failure? Yes, good, 12. Yeah? Because, remember what we said? Over here, there's 12 trials. Yeah, so you're going to go trial by trial. Failure, 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 failure. 12, loads of them. Yeah, so 0.75 to the power of 12. Yeah? Now, guys, if you type this in your calculator, 0.75 to the power of 12. So you get the same answer. Now, this is really important for the inequality questions, which is why I'm reiterating this point. So whenever you see, oh wait, that should be 1,7. Whenever you see x equals 0, yeah, I want you guys to be thinking about all failures. Really important, yeah? Now, probability that x is bigger than or equal to 3. In our calculators, we have the cumulative distribution. Now, if you're looking at this calculator, the ClassWiz, the cumulative distribution starts from 0 up until a certain point. If you have the CG50, you can set the lower to be 3 and the upper to be 12. And then it's nice and simple. But anyone who has a ClassWiz, how do you need to rewrite this probability so that you then can use the cumulative distribution? Will we ever be tested on this formula in an exam, like applying it, or do we have to use our calc? Abdul, it will mostly be with just your calculator. You don't need to worry about them. They will never ask you to derive this formula or understand in depth what it means. The only time you might need to, there's only like one or twice in my full course I give my students a situation where they need to actually use the formula. But otherwise it's very rare. Okay, good. So here, so what does this mean? You have 1, 2, 3, 4, 1, 2, 3, 4, 5, all the way up to 12, right? Now I want to know what is the sum of all of these numbers. But with our calculator, we can't do those groupings, yeah, if you have the ClassWiz. The ClassWiz can only sum from 0 up until a certain point. So what we're going to do is do everything. Yeah, we're going to go from 0 to 12, but we know that's just 1, isn't it? All of these add up to 1. Subtract anything up until 2. Yeah, so that's the probability that x is less than or equal to 2. And we're just going to type that in. So I'm going to show you how you would type in the ClassWiz much quicker than, trying to remember numbers. So go menu 7, then go down to the binomial CD. Then we go into variable. Here you're going to type in 2, n is 12, and then 0.25. Yeah, so we get this. Now, rather than writing that down, personally I don't write it down because you get a mark for saying 1 minus. And then we're just going to do 1 minus this number. So what you do is you can store it if you want, but the calculator is going to remember this number. So you just go menu 1, then just do 1 minus answer, and it does it for you. So you don't need to store any values. You just go to the original menu and the number gets saved. So we're all good. Nice. Let's get some noise in the chat, guys. We're warming up our brains. Yeah, so with the previous spec, so when I was doing A-level maths, our calculators didn't do all these fancy calculations that you see. So we had to use something called the probability tables. If you guys go into the formula booklet, you actually see the binomial probability tables, and we all had to use those. It's very frustrating, but now the calculator does do everything. You get the numbers at the back, right? Yeah. But the problem with the tables, the binomial tables, is they're restricted to the number of trials. So you can only have like 10, 12, 15, 20, 25. It goes up in like 5s or something. So here I can give you guys as many number of trials as I want. And I think the probabilities only went up by 0.5. So, now I can give you guys crazy probabilities. Is the table useless now? Yes. Ryan, I would say the table is quite useless. I don't know why they've kept it in, but it is what it is. It's probably because if they removed it, then the whole booklet becomes quite thin. But anyway, yeah, if you forget your calculator, then you have to. But then if I give you a random number trial, then you're gonna have to calculate it manually. Zayn, if your teacher taught you the table, then they have wasted a lot of time, and I'm very sorry that they have wasted a lot of time, but it is what it is, isn't it? You're learning with me now. Next one. Do you do questions in the large? Yep, for sure. Neutro. When I do papers, I split it up. AQA, EdXL, OCR. I look at the large data sets for all of them. So, next one says, Marie and Anand have a hobby of coin flipping. As you do, innit? We all have hobbies and something. Some people like flipping coins. They use a coin which is biased, with the probability of landing on heads being 0.4. The outcome of each flip is independent of the outcome of every other flip. Find the probability that in a series of 25 flips, the coin lands on heads exactly 8 times. So guys, when you start these questions, what should you do first? Are we going to go through the probability? Not today, Abdul. Yo, Sheriff. Thanks, man. Math online is generic. It's not just Edexcel. Marin and I got weird hobbies. Good, Carlos. Guys, and Zane, you have to outline, yeah, what you're talking about. So the first thing we should do is define what X is. X is the number. So we're talking about landing heads, right? So number of heads obtained. Guys, you get marks for this. If you miss it out, you can lose marks. So number of heads obtained out of 25. Yeah, now you can get away with just saying number of heads obtained, but I think it's important to say what it's out of. Yeah. So X is binomially distributed 25 trials, and the probability of heads is 0.4. Now for part A, probability of X equaling 8. And you guys can go ahead and put in your calculator, and I'll do it as well. What's up, Florian? What was the dream, man? As long as it's appropriate. What does it mean by independent in the question? So, Sophia, what that means is when you flip a coin, it does not affect the outcome of the next time you flip the coin. So I flip the coin once. It doesn't affect when I flip it the second time. That's what independent means. Yeah? Okay, you guys are saying the same thing. Oh, why do I keep doing this? Do you guys agree? Okay, you guys agree. So, what Hamza said. 0.1. So if I stick to my 4 decimal place rule, then it would be 0.1200, isn't it? 24dp. Nice. Hey, you guys remember the plus in the chat if you agree with someone. Alright, guys, in your calculators, what about X is fewer than 13? Actually, can you tell me as an inequality, what does that mean? Fewer than 13. Saving the world and it happens. Florian, you're destined for great things, my friend. Okay, so exactly. So guys, fewer than 13 means it cannot equal 13. So fewer than 13. Yeah. And as Tarek also said, and Amira, if you had the inequality as well, is you must always make sure that the inequality is not a strict inequality. Yeah, so right now it's a strict inequality. You need to make sure it's a less than or equal to. Yeah, which makes it 12. If I say get me fewer than 13 eggs, if you come with 13 eggs, you're going to get a slap in it. It's fewer than or equal to 12. So, guys, let's put in our calculator. Menu 7 1. Carlos, I see you, man. Do you guys agree? Was it 25? You guys are wasting my money. Eggs come in packs of 12. So if you come with 13, that means you bought 2 packs. Wasting my money out here. 0.4... Wait, what? 8462. Nice. Alright, guys. Tell me the inequality for part C. Inflation hits hard. Guys, I went to Lidl the other day. I spent 70 quid for my week on food. That's crazy. That's never happened before. I don't buy expensive stuff. I'm shopping at Lidl. Alright, part C. What's that inequality saying? Lidl's turning into Waitrose, man. Yeah, go get them gains. I can't lie. I bought 2 trays of chicken. That's what really adds to it. So more than 5 is a strict inequality. More than 5. Fewer than 11, same as the above, right? So it's not equal to. 70 quid is wild, for real. My job at M&S gets 20% staff discount. Yo, Cameron, I need to come to wherever M&S you're at, my friend, so you can give me some discounts. So, fewer than 11 means fewer than or equal to 10. More than 5 means more than or equal to 6. Alright, now all the class whizzes. How do you rewrite that inequality? If you're using the CG50, you can just whack this in the calculator. Lower is 6, upper is 10. But the class whizzes, you need to rewrite this. How would we do that? Also, Cameron, it says your name's Cameron older. Is there Cameron younger in the family? Just curious. And Cameron senior. I see you, Carlos. And Zane. Junior, older, and senior. Carlos. I've had that joke since I was 4. I'm sorry for being cringe, man. Okay, so what's going on here? Let's see if you guys are right. So we have 0, 1, all the way up to like 4, 5, 6, 7. Then, I mean, I didn't really need to do dot, 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 but you have these numbers, right? You want between 6 and 10. So the way we're going to do it is we're going to go from 0 to 10. Yes, we're going to do all of them. Then we're going to subtract up to 5. Okay, now I'm going to show you class whizzes how we can do this quicker without even writing down numbers, yeah? Now CG50 is, I don't know how you store the values once you do have, oh no, but you don't even need it because you guys have upper and lower. All right, so you class whizzes, do this with me. So we're going to go to our variable. Now here I'm going to change it to 10, 25 and 0.4. So this is less than equal to 10. What you're going to do is press the STO button and then press A. We're going to store it as A. Then go back and change it to 5. Yeah, we're going to store that as B. Yeah, so now I've stored A as less than equal to 10. I've stored B as less than equal to 5. So we're going to go menu 1. Then do alpha A minus alpha B. There you go. You don't need to write anything down. Just let the calculator do all the work. Guys, when I teach maths, I'm all about efficiency and getting the right answer rather than spending a ton of time doing... 1 second, guys. I have a guest. People disturbing me for no reason, man. What is this? Can you do that again, like how to store it? So the storing button, guys, is here. It says STO. Then you press the button above it. Yeah, so STOA. You can store any number as you want. What do you do if you don't have the STO button? Moneyball, what calculator are you using? Class Wish should have it. Allow my guy saving my A levels. I know, what is this? I'm in like a communal working space, so some people like to walk by and wave at me, trying to disturb me, man. Okay, next one says a particular brand of light bulbs has a 75% chance of lasting more than 5,000 hours. Suppose an office building uses 20 of these light bulbs, with the lifetime of each bulb independent of all others. Find the probability that exactly 15 lasts more than 5,000 hours. So guys, what are we doing first? Bro's too famous. I'm not famous, guys. I have been spotted a few times on the Jubilee line and in Weatherspoons, which is quite funny. Not that much though. Over summer, maybe like 6 or 7 students have spotted me, which is quite cool. Guys, you ever see me on the streets, man? Come and say hello. I always post them on Instagram as well. You guys should be following me there. You should tag me. Nah, it's funny, guys. I do all this because I want you guys to get the best grades in it. Towards exam season, I'll end up posting more TikToks for you guys, but I'm just warming you lot up. TikTok is where it all started, to be fair. TikTok's elite. Okay, so the first thing we're going to do is we're going to describe our distribution, right? So we're going to let x, good. So guys, you do have your distribution like Ryan and Ali said, but you have to define what x represents, isn't it? Yeah. So let x equal the number of bulbs lasting longer than 5,000 hours out of 20. Then we're going to say X is binomially distributed and other way around, yeah? So 20 and 0.75. Then we want the probability that X equals 15. So guys, you should have already typed this in your calculator. I'm putting in the chat. So what we got? Now we want binomial PD variable. X is 15. N is 20. We got 0.75. Boom. And what about part B? What's that saying? I haven't even read it yet, but I'm trying to give you guys a bit of variety here in terms of the questions they can ask you. It says, if 150 such light bulbs are used in a larger building, find the expected number of bulbs that will last more than 5,000. Yo, Frank Allen, what you saying? No, Thaddy, how should I revise? Revision, well, there's a difference between revision and learning, right? So revision is like what I post to you on TikTok. You're just doing exam questions. But in terms of learning, it's about understanding the foundations of each topic. Like right now, I'm revising with you guys, going through like exam style questions. But if we were learning, I'll teach you guys about the binomial distribution from its first principles, so you understand where it's coming from. And then you do directed questions that help solidify the understanding, right? Nice, Carlos. So guys, you just multiply them, yeah? So think about it this way. If I said, guys, I'm going to flip a coin 100 times, like Maria and Anand, yeah? You flip a coin 100 times. How many tails do you expect? Well, the probability of achieving a tails is a half. So you do 100 times a half is 50. Same thing here. 150 light bulbs are used. Find the expected number of bulbs that would last longer than 5,000. You just multiply them together. It's just 150. And the probability of any individual light bulb lasting longer than the 5,000 is 0.75. So with your calculator, you're just doing a nice simple multiplication. Man like Carlos and that. Yeah, this one, Amira, would be max 2 marks. Maybe even 1 mark, to be honest. Yeah, Outlaw, I'll show you the prices at the end. So I've been active on year 12 live stream. Don't worry, Frank, you can watch it back, but it's good you're here now. I don't think notes are useful for maths. I don't look. Neutro, the making notes is the reason you should write things down is because your brain slows down. So when you write, your brain is able to process things better. Whereas if you just watch, your brain can lose focus. You miss something here and there. So when you're learning, you should write. When you're revising or something like that, like when you watch my TikToks, I don't expect you guys to write anything down because I try and keep it short, yeah? But when you're learning, you definitely should write things down. Nice, Mars. Come on. 150. Wait, oh, sorry, yeah, I see what you mean. I don't know why I typed in 500. Thanks, guys. Oh, wait, so you get 112.5. Now, obviously, you can't have 0.5 of a light bulb, so you just round it, yeah? So about 113. Don't truncate. You don't need to truncate it. So, like, some people might write 112. But remember, what this is saying is what's the best approximation for the number of light bulbs. So you're just rounding it, yeah? If in other contexts, like at GCSE, you do a lot of truncating. But in this kind of situation, just round it, yeah? You're just looking for the expected number of bulbs. All right, cool. Next one. A casino uses a unique, non-biased die with 10 faces numbered 1 through 10. In a new game, each player rolls 40 of these dice simultaneously. Find the probability that in a single game, no die shows number 5. So guys, what are we writing down? And what's our distribution? That kind of stuff. Jay, where do I get my questions from? I make them up. Using my experience as a teacher for many years, an examiner, and also smashing these exams a long time ago. I know what you guys need to get the best grades. That's why I make these questions. Ugh, choking on my peppermint tea, man. Man, nice. Amira, X is binomial distributed 40 0.5. You're close. Just double check your probability there. Is asking ChatGPT to create questions optimal if you run out of questions in the textbook? It's a good question. If you have ChatGPT 4, maybe. I would probably say no, Frank, because ChatGPT's maths is still not the best. It makes mistakes a lot. It still makes a lot of mistakes. You can ask it to recontextualize, but it really, I would say it's a bit of a risk. It does solve things incorrectly quite a lot of the time. So guys, I would try and refrain from using ChatGPT to write questions for you. Nice on Mars. I'm glad to know. Is ChatGPT 4 worth it? I think it's nice to have, but unless you're in a professional environment, I'd probably say not so much. So if you're a student, I'd probably say everything you need is on the internet. ChatGPT can't search the internet, which is a problem. So, and it costs $20 a month, I think. Whereas what is Google's one called? Begins with B, Bard? Is it Bard? I think Bard can search the internet. So I think in time, Google's AI is going to be better than ChatGPT. Neil's video solution are going to be made by AI. Hey, Zayn, I would love for AI to copy me and just do all my work for me. So X is the number of dice that show, what is it, that show the number 5? Number 5 out of 40. So X, like you guys said, is binomially distributed 40 dice, and the probability, yeah, because I said unique non-biased. Yeah, non-biased, very important. And then like you guys are saying for the first one, no dice show the number 5. So X is 0. Now, guys, without using the calculator, what can we type in? I've explained this once before. What can you type in without using the binomial PD? We need to make sure we understand this section. Isn't Bard locked to... Oh, I'm not sure, Ryan. I've not actually tried it. Yeah, favor. I wouldn't use ChatGPT to answer maths questions still. Okay, all of you are using the right probability. Yeah, so the probability of landing a 5 is 0.1. If we don't want to land a 5, is 0.9. Yeah, but guys, remember, we're playing with 40 dice. Yeah, a lot of you are doing power 10. There's 40 of them. So we're going die by die. Yeah, we don't want them to show a 5. So we're going to the power of 40. Yeah, so just be careful. You're always raising it to the power of n. Yeah, so we're going 0.9 to the power of 40. So that's 0.0148. Part 2, exactly 4. So the probability that x equals 4. So that one, we're going to go straight into binomial PD. X is 4, n is 40. And then we got 0.1. Boom. 0.2059. More than 4. So guys, what's that inequality? More than 4. Can you always do that when it gives you... yes, Carlos, for sure. If it wanted x equals 40, you'd do 0.1 to the power of 40. And it's to do with the n choose stuff. So like when x is 0, you would have 40 choose 0, which is always 1. So you don't actually need to worry about all of those coefficients. So yeah, for x equals 0 and x equals 40, you can use this method. But it's mostly for the algebra stuff. Why is x 0 for part 1? So Ali, it says no dice show the number of 5. So 0 dice show the number 5. So 0 dice. Yeah. So what are we saying for part 3? So Hamza, you've rewritten it. More than 4 dice. What's up, MZA or Miza? Hopefully I live up to your brother's recommendation, my friend. Fingers crossed, fingers crossed. So more than 4, and Tyra, you have rewritten it as well. Let's check to see if you're right. So the problem, more than 4 is a strict inequality. More than 4. Now the first thing, yeah, guys, before you rewrite anything, like doing 1 minus, is make sure the strict inequality is an equal to inequality. So more than 4, yeah, more than 4 is more than or equal to 5. Yeah, so please make sure you rewrite it as an equal to sign first. So I'm going to teach you anything about the binomial distribution today is that make sure all strict inequalities are equal to inequalities so you avoid any silly mistakes. Yeah, I know these textbooks like to rewrite things straight away, but we're humans and humans make mistakes all the time. So be consistent with your working because greater than equal to 5 actually means 1 minus less than equal to 4. Exactly. Yeah. Amira, Nafisa. Exactly. So less than equal to 4. Yeah, so be very careful. If that was x is greater than or equal to 4, then yes, it would be 1 minus less than equal to 3. Yeah. All right, let's approximate this. So let's go menu 7, binomial CD, variable. I've got all the numbers here already. Okay, so we get this. So remember, you don't need to write anything down. From here, you just go menu 1, 1 minus answer. Ooh. So you get 0.37. Well, to 4 decimal places, the 9 rounds the 0 up to 1. Cool. Hafsa, when do we know when it's greater or equal to or just greater than? So I like to think of it as do a real life example. Yeah, so to convert it to an equal to. So if I say buy more than 4 eggs, yeah, if you come to me with 4 eggs, do you think I'm going to be happy? Yeah, so more than 4 eggs means the minimum you can get me is 5 or more. Yeah, so this is a strict inequality and this is the minimum value you can actually get. Yeah, so in the exam just use the eggs example and think like Matteo was saying, you know, if I said get more than 4 eggs and then you come with 4 eggs, then someone's gonna get a slap. End up paying 70 quid on eggs. Bring me the correct amount of eggs, please. Although I don't really eat eggs anymore. I've switched it up to granola and Greek yogurt. Seems to work nicer for my stomach. Protein, bro. Come on. Okay, this is another different style of questions. So it says a game is won if more than 4 dice show a 5. If 15 games are played, determine the probability of winning exactly 7 games. So guys, how are we going to do this? Let's see if you guys have been practicing your binomial distribution stuff. Yikes, where you buying my eggs from? Lidl, man. How much protein do you have a day? 220 grams at the moment. But I'm losing weight. Before, like a month ago, I was having 260 grams of protein a day. Tarek. Probability of more than 4 dice show. Yes. I want to see if anyone else has any contribution there. How much do I bench? My 1 rep max is 165 kilos. I did that a few months ago now. I haven't been testing my 1 rep max on bench. What was it? 167.5 kilos. I can't remember. I have the video on Instagram somewhere. This is why you guys should be following me on Instagram so you can see my gym progress. I post like stories on Instagram about life and whatever I'm doing. Ryan, I haven't tested my deadlift 1 rep max. I've got back injuries, but right now I'm doing what am I doing? 200 kilos for 3 sets of 6, which is not great. When I was 19 is when I did 220 for 5. When I was 19, I did 220 deadlift for 5. And I've got the video. But my form was so bad. There's a reason why my back's all messed up right now. Yes, I am, Uma. So, guys, it says a game is won. So, it's a different situation. Yeah, it's a different distribution at the moment. Yeah, we're changing it from what it was before. So we're talking about a game is 1 if more than 4 dice show a 5. So each game has these 40 dice, sorry. And we're going to do repetitions of these games. So we're going to change our distribution. I'm going to let y equal the number of games 1 out of 40. Yeah. Now y is a binomial distribution with n being 15. We're playing 15 games, but we need to write down what the probability is of winning a game. We win a game if more than 4 dice show a 5. And we actually know that probability. This is how they structure binomial questions. Yeah. So we have that probability is 0.3710. What's the probability of winning exactly 7 games? What's the probability of y equaling 7? Yeah, these questions here are about 3 marks. And they're simple once you practice enough. Yeah, so here we're going to go binomial PD, variable 7, n is 15, then 0.3710. Yeah, so here we're using binomial PD here. So the probability is 0.1525. 0.1525. Cool. Yash, bulking tips. Drink a gallon of milk a day. Thanks, Hamza. You find the probability of winning. Nice, Carlos. What was my calorie maintenance when I was bulked? About 3,700 calories. In an alternate universe, Neil is a fitness influencer. Well, Zayn, I'm actually a qualified personal trainer as well. I'm just not practicing anymore. Is it okay to use a rounded value instead of the exact value? Ryan, do you mean for the probability? If you're talking about the probability, then you use whatever value you had in AIII. Yeah, so the rounded value is what you should use. In the exam, they will give a range, but technically, you need to use whichever value you calculated in the previous part. Yeah. Gallon. Zawad, the summer course, just message me on WhatsApp. The link is in the description. How do you calculate your maintenance? Ism, you need to just experiment. You need to eat the same thing every day and just see how your body reacts. That's how I do. I do the same thing every day. Maths teacher by day, gym merchant at night. For real. Okay, so guys, just to mention again about the summer course. So next week is the final lesson. I'm going to do a mechanics lesson with you lot. But then after that is when my year 13 course starts. And then I'm just going full blast with all my year 13 students. Now, this is the overview of what you can expect over the past, over the year. Yeah. So thanks to all of you who sent me the code word sum already. They're already preparing for the 4th of September. So over the course of the whole year, you're going to have 144 hours of teaching time. That's 4 hours a week for 36 weeks. Then, so 2 lessons a week. Yeah, 2 2-hour lessons per week. For each of those lessons, 144 homeworks. I mean, sorry, for each lesson, there's 1 homework. So you'll get, actually, it'll be 72 homeworks, not 144 homeworks. That would be per hour. You'll do 144 hours of homework, but you have 1 homework per lesson. Each homework has 10 questions. So that'll be 720 questions over the whole year. And I record video solutions for every single question. Yeah. Meaning, if you guys do a question like you're using the textbook, right? You do a question, you go to the end, you see the answer, you get it wrong. A load of students just move forward and they ignore it. Yeah. Whereas I record video solutions showing you exactly how I would do the question so that all your misconceptions get addressed. And also, this is the main bit. This is, you're never going to find this. Yeah. Guys, if you find this somewhere else who's going to do this with you, I'll walk you through 62 papers before your exam. Yeah. And we start this after Christmas. I'm doing paper. You need to see how I will address papers so that you can adopt the same mindset as me. Yeah. So there'll be 31 papers in lesson time, 31 papers you get for homework. Yeah. So you're never going to find this anywhere else. No one's going to write. And all these papers have been written by me. Yeah. Now that's just the standard. If you want pro is I will guarantee you an A or A star. Yeah. Again, no one's going to guarantee you an A or A star with what I'm giving you and for the price. So I'll guarantee you an AA star and I'll give you a mentor. So these mentors are handpicked by me. They've all got their A stars at A levels already. They're going to top universities. So you use these people as your personal trainer, basically. They're there for you outside of lesson time to help you with questions, help you with uni applications if you want to ask them for support, and just general university or life questions. They're there to help you. Yeah. So that's what the personal mentors are there for. And as you can see from here, the Trustpilot is 5 stars. Guys, everyone who comes on my course and really uses it, enjoys it, and you can see the progress. Yeah. And Neil, do I contact my mentor? Yeah, they'll be available from the 4th. I'm just gathering up all the mentors still to make sure that you guys get the best quality. So you have live lessons from 6 to 8 on Monday? Yeah, Outlaw. Just like this, like we have it now, that's what it's going to be like. I kick it off with all the algebra stuff, get that out of the way. Would you ever sell the past papers and exam style homeworks without the tutoring hours? Carlos, I'm not sure. Haven't really thought about that yet. Are the streams of homework same both? Yeah. So guys, whether you're in standard or pro, it's the same course. It's just people in the pro get the guarantee and the mentor as well to help them. Yeah, Neutro. Even if you're at guys, if you're at SC and you get the pro, I'm still going to guarantee you an AA star, but you need to, you know, there's still terms and conditions this in terms of you guys completing every single question, you know, all this kind of stuff in my homeworks and working with the mentor. I'm also going to be introducing assessments, monthly assessments and stuff for students. So keep that in mind. Yes, Neutro, you can ask them further math stuff. I'll make sure that the mentor you have has experience with further maths. They might not be able to answer everything, but then they'll ask me for assistance with that. Is there further maths content on the... no, Carlos. Further maths is a separate course, which this is for normal maths. Might not be able to... Outlaw messaged me, but if that's the case, remember all of these are recorded. Yeah, so all of these lessons I do will be locked away in terms of like only students on the course can see them. But yeah, if you miss a lesson, it's all good because I have it recorded. You can catch up. Cameron, wait till the end. I'll show you. How much would the homework take to do every week? So 10 questions. My video solutions for all of them take me about 40 minutes per homework, but that's me. Yeah. So for you guys, it'd probably, you know, at least double that to complete one of my homeworks. So probably about 2 hours per homework. You know, some homeworks you might find easier than others. So yeah, I'll probably say on average, maybe about 4 hours a week of homeworks. Amira, that's strange if you've messaged someone but no reply. I've got mods in my chat. As you can see, NeilDoesMaths is commenting in the chat. One of my team should pick it up. But yeah, if it's still no, just do another one and hopefully, well, someone will get back to you. Otherwise, message me on Instagram. I'll make sure Oh, you got the reply. Sweet. What's the guarantee about? Abdul, the guarantee is just saying, look, if you do all my work, because look, some students still, even on the standard package, if they don't have that somebody there to kind of hold them accountable, then they don't do all the work. Yeah, so people on the standard course can still like miss homeworks and this kind of stuff. But if you really want to get the A star, you have to do every single homework of mine. You need to do every single paper that I create, all of that stuff. So if you do all this stuff, I will guarantee you the AA star. Raz, 6 o'clock. If we get signed and decide we want a mentor, yeah, Cameron, that's completely fine. Okay. If you do all your work for standard, math online. If you do all the work for standard, that's fine, but you bought the standard, so you wouldn't get the guarantee there. But if you get the A star, that's obviously incredible. Carlos, just wait to the end, and you can see that, and you can ask me more questions if you want. But like I said, guys, next week is the last summer course lesson I'm doing with you, then I'm kicking off and focusing on all the students, all the grinders on my full course, innit? Do you think just the work on the course outside of schoolwork? Yeah, neutral, as in my work alone will be enough for you to get the AA star if you do it all. But then if you do your schoolwork, obviously on top of that, that's incredible. So, one more binomial question before I show you some hypothesis testing stuff, guys. What are we starting with for the first? I think it's algebraic methods, Zain. So it says in a large software development company, 25% of developers use a Mac as their primary machine. Bun Macs, innit? I'm using Dell. Developers are selected at random for a survey on their preferred development machine. How many developers should be chosen to ensure the probability that there is at least one developer using a Mac is greater than 0.99? Bit of a tongue twister here, but guys, read it again and give me a suggestion on what we should write down first. Hell, Mac. Windows on top, for real. RIP to all the Mac users. Okay, good. Describe the test at first, Moneyball. So we're going to describe what X is. Yeah? As a Mac user, I agree. So X is the number of developers who use Mac. Now, what's missing? What's missing in this problem? Which is the point of this problem, to be honest. What's missing here? What haven't I told you guys? Good, Tarek. Number of good, Ryan. Good, guys. HP is the GOAT. Umar, that's questionable. I can't lie. Even though they use Windows, you know, HP computers have done me dirty over the last few years. So they haven't given us the number of users. So I'm going to say out of N. Yeah. Now, X is binomially distributed. The number of Mac users, but the probability of a success is 0.25. Now, guys, in the chat, it's all about what they've given us. They've said how many developers. So what does N need to be such that the probability of at least one developer using a Mac is greater than 0.99? Can you guys convert that statement into a mathematical statement? So forget about the how many developers. We're trying to find N. But that last highlighted bit, can you have a go at converting that into a mathematical statement? Mira, don't use trial and error. Because you'll get 0 marks for that, unfortunately. You could do trial and error and get the right answer, but you would get 0 marks there. In the exam, they'll say show you're working, that kind or answers based on graphical situations or something like that would get 0 marks. I hear you, Uma. That's a different situation there. Samsung Book 2 is next level. As long as it's Windows, man. Expected outcome? Not so. I mean, like this, Moneyball. So probability of something has to be greater than 0.99. So it's going to be inequalities and that kind of stuff. So I've kind of given you guys a layout here. Hamza, probability. You're close, Hamza. Very, very close. Make X 0. Carlos, I see what you mean. That's going to be in the next step. Ali, you have said the same thing essentially, and Ryan. So guys, when I say at least one, go back to the eggs. Yeah. If I tell you go to the shop, get me at least one egg, what's the minimum number of eggs you can get me? Yeah. Equal to exactly. Yeah. So just always use the eggs example. Yeah. And just remember, if you get the wrong number of eggs, you're going to get a slap in it. So the minimum, guys, if I say go to the shops, get me at least one egg, you can come back with one egg, it's all good. Yeah. You can come back with 2 eggs, sure. But the smallest you can come back with is 1 egg. Has to be greater than 0.99. Yeah. Long day, long day. Zawad, it's a hypothetical thing. So you guys can think about it in the exams. If you guys come to me with the wrong number of eggs, come to the wrong number of eggs, then I'm going to lose all these gains, man. Now, from here, we have to think. So even if you've got the CG50, you're going to have to rewrite it because n is unknown. Yeah? So guys, in the chat, how do you rewrite this? Because we want to rewrite in a way that we can then utilize n. And then this is going to get back to what we were doing at the beginning and why I wanted to reiterate something. So how do you rewrite the probability that x is greater than or equal to 1? For sure, Ryan. N is not 1, Abdul. N is not 1. N is unknown. So I'm saying at least one developer, at least one means greater than or equal to 1. Okay, cool. So greater than or equal to 1 means the only option we are not allowed is 0. Yeah? So this changes to 1 minus the probability that x equals 0. Yeah? Think about your number line. 0, 1, 2, 3, 4, 5, ... I'm saying greater than or equal to 1. So we do everything minus probability that x is 0. Now, when you rearrange this, yeah, you move this over here and the 0.99 comes over. You get the probability that x equals 0 is 1 minus 0.99, which is 0.01. But it's still like this. But if we write it the other way, yeah, probability that x equals 0 is less than 0.01. Yeah, like Carlos, you said. Now, guys, we practice this a lot now. The probability that x equals 0. How do you rewrite that? How do you rewrite the probability that x equals 0? Remember, n is unknown here. Thanks, Zawad. Zayn, you're close. X is 0 means all failures. You've done all successes. 0.25 is the probability of success. Okay, good. 0.75. Yeah. So remember, x is 0 is all failures. This is why I've been reiterating this from the beginning. So 0.75 n times, yeah, is 0.75 times by itself n times to the power of n. Guys, how do we solve for n now? Zayn, you can. Essentially, you can use Lun if you want. What do you think most people would do? If you guys want to use Lun, if it's your favorite, exactly logs, yeah? If you guys want to use Lun, for sure. The exam, when you guys read the exams, yeah, they're just going to take log, yeah? Now, Abdul, you wrote log base 0.75. You can use that. Be very careful, though, because 0.75 is between 0 and 1. 0 and 1. You have to acknowledge that when you do log base 0.75 of both sides, the negative is going to cause the inequality to switch, yeah? But I'm going to show you guys what the exam mark schemes will use. So doing log of this, the n can come down. So it becomes m log 0.75 is less than log 0.01. And here, yeah, guys, if you type it in, type log 0.75 in your calculator, it is negative. So when we divide, the inequality is going to switch. And we can type that in. Where's my calculator? So menu 1, and you could check it. So in your calculator, you have to do log base 10, but it actually doesn't matter. Ooh, 0.75. You'll see here it's negative. Yeah, so that's why the inequality is switching around. So we're going to do log base 10 of that 0.01. And I've already typed in the other one. So there's 16.007. Okay, so guys, what's n then? What are you guys going to say n is? Okay. Carlos is 17. Moneyball 16. Amira 16. Okay, it's mixed. Zayn, where are you getting 4 from? Would you get marks if you did a log with a base? Yeah, Matthew. So if you type in your calculator, log base 0.75 of 0.01, you're going to get the same answer. But you need to consciously switch the inequality, yeah? Now, guys, I've done this on purpose. I like putting in all these little nuances in my work because it looks like it should be 16, yeah? But guys, if you type in your calculator 0.75 to the power of 16, it's going to be ever so slightly more than 0.01, yeah? N has to be greater than this value, so N is actually 17, yeah? So I do this on purpose to make sure you guys are ultra focused at all times. You can't have half a trial, so it should be rounded down. So yeah, it's not about that, Moneyball. It's about having the sufficient number of N, which ensures the probability is smaller than a certain value, yeah? So if we here do 0.75 to the power of 16, you see it's ever so slightly greater than 0.01. We can't have that. You'd have that incorrect. So it has to be 17, where you see it goes below, yeah? Same with the 4. I'm slightly confused on the latter half of the question. So Harrison, N is in the power. To solve anything where the unknown is in the power, you need to take logs in order to use your log rule to bring the power down, yeah? How do you know from looking at log 0? So Jay, the log graph looks like this, which you guys should all know. Yeah, can you see between 0 and 1, all log graphs are negative. Yeah, that's why. So you need to also know what the log graphs look like. So whether it's log base 10x, log base 2x, lun x, all of these, they all look the same. Between 0 and 1, they're all negative. Okay. Now, guys, let me show you a bit of hypothesis testing. Now, if you saw my TikTok, I did upload, or I do love to upload, a hypothesis testing question. Now, I'm going to show you guys a one-fits-all approach, which is to find the critical region, yeah? Now, the critical region, the reason I emphasize it a lot is it addresses 2 questions in one, because with hypothesis testing, they can ask you to find the critical region, or they can ask you a probability. So by doing the critical region, you do a one-fits-all approach, yeah? Weird question. When replacing Casio CG50 batteries, do I place them with specific... No, it doesn't matter, Math Online. What's up, my brother? Zawad told me there's a Merab, I think Zawad said he was enjoying the stream, so I think you're in the right place, man. Okay, so guys, hypothesis, a battery is a battery. Energizer, whatever they're called, claims that they're the best, though. So, you guys should have already seen hypothesis testing, so I'm not going to explain hypothesis testing from its foundations, but we're going to practice. So it says one-tailed tests are where we are looking at one end of the binomial distribution. So let's just get straight into it. So it says the default rate on a certain type of loan according to past records is 0.15. A financial advisor, Jill, is appointed to help clients with this type of loan. In the next batch of 50 clients that she assists, 4 defaulted on their loans. Is there sufficient evidence to suggest that Jill's default rate is lower than the standard rate? Test at the 5% significance level. Okay. Lun Gang, Mr. Neil got A star. Yo! Actually, respect. Guys, that's a W for... Actually, let's get that in the chat. Well done on getting your A star, my friend. If you want to potentially be a mentor for me next year, hit me up, man. And good Zane, we need to define X. Guys, W's in the chat. This is going to be you guys next year, innit? Getting the A stars and that. So, let X equal the default rate. Or number of clients who default out of 50. Let's change that. Number of individuals who default out of 50. Yeah. So with binomial, guys, always say number of. Yeah. Number of. So X is binomially distributed 50 individuals, and the probability historically of defaulting is 0.15. But then what's the next thing we will do? SLG, opinion on the grade boundaries this year. I think it was fair. I think the exams were quite easy, so they were always going to be higher. The proportion of people who got A's and A stars is now nearly the same as what it was in 2019, as it should be. It was like, what, 26, 27%? It makes sense. Amira, you'll always remember Lun Gang for the rest of your life, even if you don't do maths for the rest of your life. Okay, so H0 and H1, yeah? So H0, yeah, H0 is what you're assuming to be true unless proved otherwise. And that's that 0.15 is the default rate, yeah? Now H1 is the alternative hypothesis. So guys, reading the question, what would be our alternative hypothesis? What would be our alternative hypothesis? I see you, Zane. Henrietta, please, I don't know. Henrietta, it might be better to start from the beginning, but just see how you go. We're just starting hypothesis testing, but afterwards, just rewatch the stream from the beginning. Yes, Amira. So whatever the probability stated is going to be your H0. Now it says here, test, is there sufficient evidence that the default rate is lower than the standard rate? So we're testing to see, is it lower than 0.15? Now from here is where we find the critical region. I'm doing this kill two birds with one stone, yeah? So the way we do that is we draw a really quick picture of the binomial distribution. Now the binomial distribution is just a bunch of bar charts, yeah? Now anyone who was on my year 12 course last year know that doing this is really quick once you practice, yeah? Like you can do this in literally 2 or 3 minutes, yeah? It's just you need to practice. Can you combine and solve it that way? What do you mean by that, Moneyball? So, guys, the bars, the height of the bars is the probability, and these are your various x values. When you look at this distribution, which x value will be the most probable event? What would you have to do to the 50 and the 0.15? So you have 50 trials, the probability of success is 0.15. How do you calculate the most probable event? I see you, Zane. See what other people think. Could quickly do on the calculator. Yeah, we just type it. We just multiply them. Yeah? Our teacher taught us to like join the H0 and H1, then you solve it like that. Moneyball, I don't actually know what that means. If you have an example of how you did it in school, you can send it to an Instagram. I can have a look. Yeah, that might be better. So send me a picture of like you're working out of a question on Instagram. So yeah, guys, to find the most probable event, you just multiply them together. Yeah, so like if you're flipping coins, yeah, if you're flipping coins and you have 50 and 0.5, the most probable event is 25, isn't it? You just multiply them together. So the bars, yeah, the tallest bars will be at, you know, 7. Well, what is that? 7.5. But we know that the binomial distribution is a discrete distribution. So you can't have 7.5. The tallest bars will be 7 and 8. Yeah. But it's just for your kind of visuals. Yeah. So 7 and 8. You don't need to put them there, but it's just for your understanding. Yeah. And it will go down to 0. And then these bars would go all the way up to 50. Yeah. But it's just a sketch. Yeah. It's just a sketch. Now, we are saying, so guys, listen to me carefully. We are trying to find how few people would have to default in order for us to say that 0.15 is probably an incorrect probability and it should be lower. Yeah. So we're saying how few individuals need to default in order for us to suggest that the default rate is lower. Yeah. So this is what we call the critical region. We draw a vertical line and we say this region is how few people need to default in order for us to suggest that 0.15 should be a smaller probability. Now this whole region here needs to be 0.05 or less. Yeah, that's the 5% significance level. And all we do is go on the calculator and find which value tells us 0.05 or less. Yeah. And it's a cumulative distribution. So guys, do it with me. So we're here. Go down. We want the binomial CD variable. Now n is 50 and p is 0.15. You just need to play around with the different x values. Yeah, you need to find me the largest number, which is 0.05 or less. Carlos, you said 3. For example, if I typed in 5, that's 0.219. That's 22%. That's huge. I want 5% or less. Yeah. So if I try 4, that's 11%. Yeah. Still too big. 3. Okay, good. Carlos, you're correct. Yeah. So you can see this number here is 0.05 or less. Yeah. So that number was number 3. So 3 is within the boundary. Yeah. Can't use the table. You can, Ryan. But when the numbers become larger, you would have to type in quite a lot of x values to see the which one is appropriate. Yeah. So the probability that x is less than or equal to 3 is 0.0460. Oh, that's fine. So our critical region is any x value less than or equal to 3. Yeah, so anything here, you would reject H0 and say, look, these are too few people to default in order for us to say that 0.15 is the correct probability. Yeah. Now, Jill, in her situation, 4 defaulted. But 4 is over here in our diagram. 4 is in the acceptance region. Yeah. So we are going to accept H0. Yeah. So 4 is actually bigger than 3. It's not in the critical region. So we're going to accept H0. Yeah. Then we're going to say there's insufficient evidence to suggest decrease in default rate. I think the table school taught us was useless. Absolutely, Merab. You should not be using binomial tables for any of this stuff. I'm sorry that you've been taught that way, my friend, but that's bad practice. We're not doing the old spec anymore. When I was doing my A-levels, I would have to use the tables, but you guys should never, ever have to look at the tables to do any of this stuff. Matthew, probably another 15 minutes maybe. I've got 2 more examples of this to show you. Okay, so basically you assume H0 to be true. Essentially, Moneyball, that's another way you could do it. So that's the p-value way. You calculate the probability of x being less than or equal to 4 and see how that compares to 5%. But the problem with that is if I ask you to find the critical region, students become very stuck and they don't know how to calculate the critical region properly. So this is why I suggest you just do a one-fits-all approach and do this way. Yeah. No, Eddie, I won't be doing the normal distribution today. 3 weeks down the drain for sure. Henrietta, what does bold mean? What do you mean by that? Sorry. Our teachers did a whole week where we are forced to use the table. Akua, I'm very sorry that your time was wasted there. You definitely do not need to use any tables. Do you have to find the critical? So Tarek, like I've said, you can do that way. It's absolutely fine. You'll get 4 marks. But if I ask you to find the critical region, then there's the issue. If you don't practice it, then when you get to the real exam where it really matters, you're not going to be conditioned enough to do it. And students make mistakes all the time. I've marked hundreds and thousands, well, not hundreds of thousands of scripts where students just stall when the question asks them to find the critical region. Would we ever? Yes, Carlos, with the normal distribution, in my full course, I teach you guys how to calculate critical region with the normal distribution. It's very easy. Calculator does it all for you. Aaron, would you get marks if you do not reject instead? Yeah, that's fine. Just get used to just saying accept H0. Accept to reject. Keep it to that. Yeah. So you passed A-level at 16. Merab, yeah, at the end of year 12, I'd already done my A-level maths. Got 100% in basically everything. Okay, so I did do further maths, and I also got basically 100% in every exam. It's just I don't have a further maths course at the moment. So next question, guys, says the success rate for a new software patch is believed to be 0.7 based on historical data. David, a new project manager, oversees the next round of software patches. Out of 30 patches overseen by David, 25 were successful. Is there sufficient evidence to suggest that David's success rate is higher than the historical rate? So, let's just say X is the number of successful patches out of 30, isn't it? Now, X is binomially distributed 30 and 0.7. So guys, what's H1 going to be here? So the probability is 0.7, but can you guys tell me what H1 would be? Yeah, should I do steps? So I did the Advanced Extension Award. I didn't have to do it, but I thought, YOLO, A-level maths is too easy, so I'm going to do the Advanced Extension Award, which is the AEA is equivalent to step 2, I think. Step 2. If you get a distinction, the AEA is equivalent to step 2. And I did that. I did the AEA at the end of year 12. So I was 16 at the time. I got a merit. I wasn't happy with that. So I did the AEA again at the end of year 13 and I got a distinction. So the equivalent of step 2. But I didn't need it I went to UCL to do maths. But yeah, I would have. With my grades, they were equivalent to get me into Cambridge, but it's I didn't actually apply for Cambridge. But oh well, UCL was a fun time. Okay, good. So probability is greater than 0.7. Yeah, success rate is higher. So same thing, guys. We're gonna do a graph. So where's my tallest bar gonna be? Would I have gone to Cambridge? Yeah, if I had an offer, for sure. Yeah, I would have gone to Cambridge. Anyone, well, maybe not anyone, but if I did apply to Cambridge and got in, I for sure would have gone. Yeah, I could have done a postgrad at Cambridge if I wanted to, but after UCL, I was kind of done with degree level maths. And I did get a first at UCL maths as well. Ali 17.5. How did you get that? I didn't do the UKMT. When I was in high school, I went to a ghetto school, innit? So they didn't really encourage us to do anything apart from go to detention. Are you familiar with the specialist maths in Australia? Not familiar, Eddie, but if you want to send me some stuff so I can look at it and see if I can help you with my courses, then for sure just message me. I started my A-levels in year 11. So guys, here we got 30 times 0.7, yeah? Like Tyra said. Ali, be careful, it's N, yeah? So the 25 was successful is like the outcome of our experiment, right? But for our distribution, yeah, the tallest bar would be at 21. Then the bars would go up to 30. You don't really need to count. Remember, it's just a sketch. Yeah. Now, guys, are we looking on the right side of my distribution or the left side? Keeping an eye on this inequality. Are we looking at the left or the right? Oh, Merib, you went to Tiffin. Nice. Do you know how to get access to the UKMT mentor sheets? I'm not sure, Carlos. Sorry. Henrietta, I started A-level maths when I was 15 years old. Okay, good. We're looking at the right. Yeah, so greater than, we're looking at how many people is enough for us to say that the probability is actually greater than 0.7, right? So we're looking over here. All right, so this area needs to be 5%, 0.05 or less. But the problem with that, guys, our calculator cannot help us for that situation. So we need to reverse it. Yeah, so I'm showing you guys how you do it on the right side. Now, if the left side has to be 0.05 or less, what has to be true about the right side to ensure that the left side is 0.05 or less? What would that have to be? Yes, Neutro, luckily. But this was like a long time ago now. I think times have changed. Good. So guys, like what Hamza and Jaden said as well, and Abdul, you did as an inequality. So it is 0.95, but we need to say or more. Now the reason for that is we make sure that we read our calculator properly. Yeah. Now guys, can you all go on menu distribution 7? Can you find me the cumulative number which is 0.95 or more? Type this in, but I want you to play around with the different x values. Find me the first number which is 0.95 or more, and then we'll check it. CD, Hamza. So remember, all of this hypothesis testing stuff is cumulative distribution. Yeah. So Ali, you're saying 25. Carlos agrees. Henrietta, I think you might be slightly behind. Just check the bottom corner. Does it say live? Otherwise, refresh your screen. PD, Abdul, means probability distribution. That's the probability of an individual bar. Yeah, how high does it go? But we're summing them all up. So we're going to go down, binomial CD. So N is 30. Hamza, you're saying 25 as well. P is 0.7. So let me check. So you guys are saying 25. Zawad's saying that. Okay, that is 0.95 or more. I'm going to check 24 just in case. Yeah. Okay, you guys can see that 0.92. So that's not the one. Now, guys, be very careful. Yeah, be careful. It is 25. Yeah, it is 25. That is 0.95 or more. So that goes here. Make sure you put it in the right place. Yeah. 25 is 0.95 or more, which means 26 would be 0.05 or less. So it's 26 that's in the critical region. Yeah. So you can write down some probabilities. Less than equal to 25 is 0.9698. And the reason this is the case is because of how we would calculate greater than equal to 26. You do 1 minus the probability above, which is 0.0302, which is less than 0.5. If you guys calculate the probability of bigger than or equal to 25, you'll do 1 minus less than or equal to 24, but 24 wasn't 0.95 or more. So you guys need to make sure you put in the right place. So your critical region here is X is bigger than or equal to 26. But David found 25 was successful, which is not in the critical region. 25 was actually on the boundary. Yeah. So this is why, I put, generally speaking, if you learn a lot more with me, you'll realize that when I do these hypothesis testing questions, my numbers are very close to the boundary, because so many students, they will say 25 is the one in the critical region, they get it wrong. And they have to really understand why it's incorrect. So 25 is less than 26. So again, we're going to accept H0. Now guys, the conclusion here, I'll just say it verbally, is that there's insufficient evidence to suggest that the new project manager has increased the number of successful patches or something like that. Yeah. Cool. So you can see it's actually just calculator work. You don't need to do anything special here. You just draw the graph and then, you just go with that. So one more question I'm going to do with you guys is just a quick two-tailed test. Now, two-tailed tests are where you don't know whether you're testing greater than or less than. So we're just testing for like changes. Yeah. I lied. I didn't go. You guys are obsessed with Tiffin school all of a sudden. Now, if this happens as well, when we do a two-tailed test, you just need to divide the significance level by 2. That's all. So let's just do a question. And we look at both sides of the distribution, so right and left. So it says the local council initiated a campaign to increase recycling rates in the community. Prior to the campaign, it was estimated that only 30% of households were actively recycling. After the campaign, the council conducted a survey to assess its impact. A random sample of 40 households was selected, and it was found that 18 were recycling. Test at the 5% significance level whether or not there is evidence to suggest a change in the proportion. So keyword, guys, which when you read the exam question is this word change. Yeah, change means two-tailed, greater than, less than. These are all one-tailed phrases. Yeah, they might say test whether the proportion is different. Yeah, that's another word which they like to use for two-tailed tests. All right, cool. So step one is we're going to define X. Yeah, so X is the number of households who recycle out of 40. What would be good is, guys, on a piece of paper, maybe draw the diagram and see if it matches up with my one that I'm going to do in a second. So X is binomially distributed 40 households, and the probability at the moment is 0.3. Our H0 is that the probability remains at 0.3. But H1, yeah, is where we're talking about it changing, something different. So the probability is not the same as 0.3. Okay, guys, where's the tallest bar going to be? Hope you guys have done that bit. So here I'm going to make sure that we all know how to do this critical region business. Zawad, whichever's easiest for you. Whichever one you prefer. Where's the tallest bar going to be? Let's get my... Looking at this distribution. Tarek saying 12. Matthew as well. So we're getting that by doing 40, the number of trials, times the proportion of success, isn't it? So good, 12. Yeah? So, it's not that important to label it as 12, but, you know, it just gives us an idea of the kind of skewness of the distribution. Yeah? So, we have bars on each side. Yeah, remember, it's just a sketch. You don't need to make it really nice. But we're looking at both sides now. Yeah, we're saying, look, this side, yeah, and this side, together, they need to make up 5%. Yeah, so we're going to half the 5% and say 0.025 or less. 0.025 or less. But what do we have to do with one of them? Abdul, I can't remember. It might be pulley stuff, like lifts and that. I can't remember exactly. Maybe 2. I'll have to double check. If you check my YouTube playlist, you'll see what next week's lesson is. But in terms of my diagram, guys, what needs to change here? Something I need to rewrite. Nice, Aaron. So, guys, the right side, good Hamza as well. The right side, this side, needs to change so that we can use our calculator. Yeah. So 0.025 or less, we do 1 minus that is 0.975. But we want it or more. Yeah. Okay, so guys, I want you to do the right side for me. So find the number with that distribution. What is the first number, which is 0.975 or more? And then I'm going to do the left tail. So in my calculator, I'm going to go menu 7, go to my cumulative variable. Now x, yeah, I'm going to play around with that value, but n is 40 and p is 0.3. I'm trying to find the biggest value, which still remains under 0.25. So should I try 10? All right, that's massive. Okay, so I'm way off. 5? What is that? That's 0.008. So it's quite small. 6? Ooh, that's really close. So that's just under. So I'm assuming 7 is going to be way off. Okay, 7's too much, so it's 6. So the answer for me is 6. Yeah, the probability that x is less than or equal to 6 is 0.0238. Okay, so that's one side. Carlos, you're saying 19. Let's test it. So 19. Aaron saying 18. Tyra saying 18. So 0.9937 is definitely bigger. But we now want to see, is there a smaller number? You guys are saying 18 now. Okay, that's still bigger. Should we try 17? All right, 17 is just smaller, isn't it? Yeah. So it's 18. 18 is the value that is 0.975 or more. Yeah. 18. Yeah, because the probability that x is less than or equal to 18 is 0.9852, which then means exactly that 19 is the one that's in the critical region. I don't know if Carlos and Tarek, that's what you meant. So the probability that x is greater than or equal to 19 would be 1 minus that, which would be 0.0148, which is less than the 0.025. So my critical region is x is less than or equal to 6 and bigger than or equal to 19. Yeah, this would be regarded as a tough critical region question. Yeah, but it's actually not that difficult once you practice it a few times. But if you try and use the probability method of finding the critical region, you're going to have quite a difficult time. That's why we use the diagram. That's why I advocate for the diagram. Now, they had 18. Again, on the boundary, you guys know how I do things. 18 is actually less than 19, so you're going to accept H0. Yeah, and then say there's been no effect, basically. I do, Ali. Not personally, but of him. Do we need the lower tail in this? Yeah, so Abdul, you should still calculate it, but it's not relevant to answer the 18. But you need to utilize it because we're doing a two-tailed test, right? Thanks, Hamza. Give me Mr. Everything vibes. But I don't even actually know who Mr. Everything is. So guys, this is would you lose marks if you didn't? Unlikely for the not finding the left tail, Abdul. But if they asked you explicitly to find the critical region, then yes, you would. If you didn't do it, yeah. But if you're doing it just to answer the general question, then yeah, you'd be fine. Okay, so guys, if you have any other questions, like I said, this is it for the next year. So guys, this is an upfront cost for the next year. It works out to like £2.50 an hour for the pro. So guys, I will guarantee you an A star or A for £2.50 an hour of your time. That's it. So if you want to make a £2.50 investment of your time, and I'll give you a mentor as well. So you get 144 hours with me and a mentor and all the homeworks for just £2.50 an hour. Yeah. Now these prices are slowly going up. Like I said, the reason for that is because, and even then it's like, this is still incredibly cheap. Yeah. You're not going to find someone who's going to guarantee you an AA star for like £500 for the whole year. Yeah. If you do, message me, and I just guarantee it's not going to happen anyway. So if you just want the standard, then it's 300 for the whole year, which, you know, is crazy. I'm trying to make it as cheap as possible for you because I want as many of you on this course with me as possible. Yeah. All you need to do is send me the code word summer. Yeah. And I'll plug you with it. But like I said, the reason the prices are slowly going up is because the platform I use to put my homeworks on charge me for a certain number of students on the platform. So like that price is slightly higher than what it was on week 1 because a lot of you sent me the code word summer and you locked in the I can't remember what it was. I can't remember what it was in week 1 anymore. But you know, as you guys have been sending me summer, I've been filling up these spaces super quickly. So yeah, if you want to lock in this price, guys, you need to message me ASAP with the code word summer. Oh, it was 400, guys, in week 1. So it has gone up. And it will continue to go up. You can see what I usually charge for the whole year. 1080 is what I usually charge for these courses. I'm giving it to you for 550, which is crazy. Yeah. So this is only because you guys have been chilling with me doing maths during summer school. But if you want to sign up, remember, I've only got one more session like this with you guys next week. But if you're interested, just send me the code word summer. I'll be happy to accommodate you, put you on my platform and all that. If you have any other questions, let me know. Hit the description, guys. You can go to my WhatsApp, message me on WhatsApp, the code word summer, and I'll happily plug you in it. Thanks, Abdul, man. I see a few students who are going to be joining me in 2 weeks' time. I can't wait to get you guys all the grades you've been hoping for. Thanks, Merab. Other teachers expecting to pay £40 per hour. So this is like what, like 12 hours or 13 hours with a one-to-one teacher. But guys, when I was doing this one-to-one stuff, I was charging 100 to 120 pounds an hour. So this yearly cost would be like 4 or 5 lessons with me. So 4 or 5 hours with me. Now you're getting 144 hours with me. So it's very, very different. So, and other teachers do not guarantee you an AA star. And those teachers don't give you the attention you deserve outside of lesson time. Moneyball, there is options for that. To split these payments. So just message me and I can get one of my team to sort that out with you. Farhan, I can't remember off the top of my head, but it's a fair amount of students who want to get them A's and A stars, innit? Supply and demand, for real. Carlos, not for further maths, unfortunately. Because I don't have a course for further maths. Nice one, Matteo. Take care, yeah? Lun Gang and that. Henrietta, the per hour price is just a breakdown for you, but I don't charge per hour. Because I'll be crazy to charge you £2.50 per hour over 144 hours. See, Abdul. Yeah, Jaden, you locked in the 500. That's amazing. So you got in before the price went up because of the platform. Oh, you're already in, Farhan. Okay, you're chilling. Remember, sometimes it might be one of my team dealing with your case, so I don't actually know all the individuals, but I will do in 2 weeks. Yeah, Merab, you can. No worries, Henrietta. No worries, Sophie. Take care. Lun Gang and that. See you, Aaron. Guys, before you leave, you can drop a noise in the chat or a Lun Gang. And I'll see you guys next Tuesday for our last summer session. See you, Jaden. See you, Moneyball. It's good having you guys here. Hopefully you learned something. Nice. See you, Tarek. See you, Alex. See you next week, Uma. Bye, Farhan. See you, Tyra. Bye, Emma. Nice. See you, Raz. Bye, Ibrahim. See you, Harrison. See you, Henrietta. And guys, if you have any more questions, you could just hit me up on WhatsApp. If you're watching on TikTok, sorry, you should come over to YouTube next time to interact with me. But in my bio, you can also check out my WhatsApp link. But otherwise, guys, I look forward to seeing you next week. Yeah, WhatsApp me, the code word summer, if you're interested in my full courses. All right, peace out, guys.